What is the inverse of a square root? This radical right here. What's the inverse? Squared. It is squared. Remember, inverse is like saying opposite. So if you want to get rid of a radical, get the radical alone. Is that x inside this radical? No. No, it's not. Okay, so I'm going to get that x to the other side so we can get that radical alone. If ever you want to get to know something, get them alone. Well, that sounds weird. Never mind, don't say that. Okay, so we have the x plus 2 on this side, because I added x to both sides, and then we have the square root right here. And you guys said if I wanted to get rid of the square root, I just have to square it. You are correct. So I'm going to square this side, and I'm going to square this side. Make sure you don't do silly things like, well, here. We'll go 2x plus 7. And don't do this. Don't do this. If you wrote this, if you thought this, you just killed a puppy. This is not right. All right? Every time you do that, a puppy dies. Like a little tiny innocent one with soft fur. And it made that noise like, you know, really loud. And it was all your fault. All your fault. You look at the puppy and now it's not happy. It's not wagging his tail anymore. All because of you.
It's dead. What do you mean? You're like, it's not wagging its tail.
Yeah, I'm just pointing out the really sad things about it. Okay, so what is this times this? We're going to have to do a box or rainbow stuff, whatever you do to do this. I'm just going to go like this and multiply those. So I get x squared plus 2x, and then I'm going to go that times that, and that's going to be 2x plus 4. Oh, man, I should have just simplified it in my head. Now I have to write more stuff.
You're just so bad.
I'm just so slow at math to try to make sure that you guys don't lose me. Okay, so now we have this x squared right here. How can we talk to your neighbors right now? How can we get x alone if there's an x squared term inside our equation? Go. Okay, I hope you heard something like this. Make it equal 0. Okay, that's going to be the first job that you do, I think. All right, so I'm just going to do two operations in one. I'm going to subtract 2x and then subtract 7 from both sides. And so I get 0 equals x squared plus 2x, and then that's going to be a minus 3. Now, if you had somebody at your table say square roots, they are logically correct, but it doesn't work. See, if I square root this side, I would square root that side. But this right here, that's not a perfect square, so I can't square root that. Because there is an x term right here, square rooting is not going to be the answer unless you complete the square. If you complete the square, you can square root, but I ain't doing that. The other way to do it is a quadratic formula. You can use quadratic formula from this point right here. And quadratic formula always works. So, but there is a faster way, and if you're good at factoring, that's the way to do it. If we factor both sides, we get x, was it plus 3 and x minus 1? What multiplies to give me negative 3 and then adds to give me 2? The answer is positive 3 and negative 1. And so I just set each of these factors equal to 0. Using the 0 property, I get x equals negative 3 and positive 1. Those are my two solutions. Oh, but wait a second. Before I box it, I need to check. Negative 3, can I plug that into this radical thing right here? Because there's a limiting operator. Here, you see this radical of square root? That's a limiting operator. You can't plug in certain numbers into this.
Wait, but it
because
would be the square root of
what can you not have inside of a square root?
Negative.
Negative.
Yeah, but it would just be
imaginary.
6 plus 7. So if you
okay,
add
so
7 to it, it's...
Oh, you're already plugging it in for me. Okay, yeah. If I plug in negative 3 to this, I get negative 6 plus 7, which is not negative. So is negative 3 good?
Yeah.
Yeah, what about 1? Is 1 good?
Yeah.
Yeah, so now I can box them. Okay.